Hello guys, welcome to my new video, and this video is going to be about inverse functions. Okay, so let's jump straight into it. So inverse functions, what are inverse functions? So over here I've drawn two sets, and this is to visually represent what is meant by inverse functions. So in here we got set A and set B. Alright, maybe I can just write that down. Set A and set B. So in each of these sets there is a value. Okay, so in set A we got this x value, and set B we have this y value over here. And this x value corresponds to a specific y value in the B set, and this is connected to each other by the f function over here. So what's this thing about inverse functions? So inverse functions is the exact opposite, where what's happening is inverse functions is an inverse that connects the value from the B set to the A set. So technically it's just a reverse process over here. It's just reversing. So the f function maps x to y, and the f inverse maps y to x. It's actually a very simple concept. And over here, as I've written, every x value corresponds to its y value, like for example the value in the B set, in the f function. So this happens in the f function, and every y value over here corresponds to its x value in the f inverse function. So the y value over here corresponds to a specific x value in the f inverse function. So to make this more clear, let's visualize this inverse function in a graph. Let's have a look if a graph has an inverse function to it. Okay, so I hope you guys actually remembered about the vertical line test. Horizontal. It's a mistake here. Horizontal. A horizontal line test. I hope you guys still remember that. So basically, we have an fx function over here. And as you can see, this function, if you were to draw any horizontal lines, they would only intersect once. Now what does this tell us? This tells us that every x value has only one y value. So what we're trying to say is each x value corresponds to a specific y value. So this is a inverse function, technically. Okay. Alright. So this is an inverse function because it only intersects at one point. Now let's look at an example where where a graph does not have an inverse function. Now over here we have another graph, and in this graph, as you can see, when we were to draw the horizontal line, it intersects at 2 points. So what does this mean actually? This means that it is a function, alright? It is a function. However, it has a y value that is mapped to two x values. And this cannot happen for an inverse function. An inverse function, sorry about that. Let me change the color. Inverse function can only have one specific corresponding value. So in this case, if you see here, in this graph, there is a y value that has two x values, which cannot be true. this cannot be true for an inverse function. An inverse function can only have one intersecting point. Okay, so let's have a look at how would an inverse function look like. In the earlier two examples we saw was a normal function, and what we did is we wanted to find out if they would have an inverse function. So the ones which pass the horizontal line test have an inverse function, while the ones which don't pass do not have an inverse function. Now let's have a look at this graph over here. How does an inverse function look like? Okay, but why not can we just test if this graph has an inverse function? So let's try the horizontal line test. So as I draw a line here, it only intersects at 1 point, 1 point, 1 point, and 1 point. So it only intersects at 1 point. So this has an inverse function. However, the question we have right now is, how does it look like? Well, a simple trick, or maybe a trick that we know, is any point in an inverse function is basically the reverse of the original function. Now let's give for example over here that, okay, look at this coordinates over here. We have a point over here which is on the x-axis where its point is -6 and 0. So -6 on the x-axis and 0 on the y-axis. So what an inverse function technically is, it's the reverse. So if the fx has a coordinate of point -6 and 0, an inverse function would technically have the same point reversed to 0, -6. It's just switching among itself. So it just switches places. So how would it look like? Okay, so if I were to find this inverse this point over here, I would get -6, 0, which would be over here. Okay, and if you were to inverse all the points, you'd actually end up getting a graph that looks like this. Now you might be wondering, wow, okay, so we've inversed the graph, and however, I noticed something. And what's that one thing I noticed? It is that it's reflected. It's actually reflected about a line, and that line is technically this line. Let me get a pen. Okay, it's technically reflected about the y equals to x line. So a simple note over here is every f inverse graph is a reflection of the f graph about the y equals to x line. So technically this is a reflection about the y equal to x line, and this is true for every inverse function. Okay, alright, why don't we apply this exact thing in the second part? So in the second part over here is we have a function f of x, let me just write it, f of x, and we want to inverse this graph. So one simple rule we can do is to plot the y equal to x line. My drawing might not be perfect, but here we go. Okay, so, oh, it's not good. Hold on. Okay, this is somewhat straight. Okay, so this is the y equal to x graph. And what we have to do is technically reflect about it. And how we can confirm this is maybe we can try to inverse this point over here. So our reflected would be 0, 1. So that means 0 on the x-axis and 1 on the y-axis. And technically, we just have to reflect it about the line. And there is a point where all three lines actually converge with each other. Alright? Let me just perfect this drawing over here. Oh, yes, okay. So this is the inverse graph. So to confirm it all, an inverse graph would technically intersect with the y equal to x line and the fx line. So you would see three intersections about this point. A specific point would have three intersections. Okay, so now we have a function and we are asked to inverse it to f minus 1, f to the power negative 1x. So the question is, how do we inverse it? Well, a simple rule of thumb is to always to make it more easier, is to change this fx into a simpler value, a simpler variable that we can change to. So why not we can say let y is equal to fx. So now y will take place of that fx. So what do we do next? Well, as you remember, the function of fx maps x to a y value. So why don't we do the same thing where now a y value, wait, sorry, I'm kind of confusing this. In this case, we have y equals to x. So we have to do the same thing where we express x in terms of y. Now, okay, you'll be able to see it when I do. So what we have to do is we have to start with y at one side, and at the end we have to end with x at one side. So that would technically be minus 2x is equal to 3 minus y. Divide by negative, you get negative 2x, y minus 3, and x would be y minus 3 over 2. So we started with a y and we ended with an x. So this is how you get an inverse function. However, we are not done yet. Every time you inverse a function, the subject of it, the variable used, must always be an x. So you must always remember to change this y value here to an x. So that would give you f minus 1x is equal to x minus 3 over 2. That's it. So that's quite easy. And the second question we have here, which is just slightly trickier, but if we apply the rule we used earlier, where we start with a y and end with a x, we'll be able to solve this all. Okay, so first off, let's start with the y. Let's express fx as y. Okay, so y is equal to 5x over x minus 6. Now this may look a little confusing at first because we have two places with an x value and we have to end with an x at one side. Okay, but let's just keep going. Okay, so y is multiplied by x minus 6 equal to 5x. And what should I do next? How do I isolate the x? Well, technically, just multiply it inside it first. Just, expand the thing first. Xy minus 6y is equal to 5x. And now if you can see, I can somewhat isolate my x to the left side, where I can do this. Xy minus 5x is equal to 6y. Right? And if you could see here, that on the left hand side, I have my two x values. So what do you think I can do here? Well, if we said factorize, that's true. We can factorize the x from these two values, where we'd get 6y, and finally we can end it with 6y over y minus 5. And are we done yet? Nope, we are not done yet, where we have to write it this manner, and remember to change the y to x. Done. So that's how we do inverse functions. Thanks for watching, guys.